All right, guys, I'm not in the most comfortable position, but I wanted to make the most of the time that I have. So it's been a dream of mine to show you guys the different ways and how to graph into one concise video. So here's my attempt. I hope I'm successful. So first, it's important to establish that when we're talking about a function or, graphing a line, it's usually in the form y equal to mx plus b. And it can also be written, y can also be noted as f of x equals to mx plus b. All right, so at this stage of the game, hopefully this is not your introduction to graphing, that you've seen it before, so you'll understand some of the concepts that I'm about to talk about. So it's important for us to establish, like I said, I'm just trying to show you the different ways in graphing in one concise video. So here we go. Let's first establish when we have to graph constants. So for one, let's say f of x or y, or y is equal to a constant b, right? This simply means that the slope is 0. Not to be mistaken that there's no slope. Not the same thing. This just simply means that the slope is 0. So when I had my y equal mx plus b equation and my m was 0, you could see x times 0 cancels out and I'm just left with b. So my actual, this actually produces a horizontal line. So produces a horizontal line. So this is what your graph will look like. Just sketching. That's my origin, my y-axis, my x-axis, right? And basically at some constant b, a line will be drawn through it. And this is saying that my slope is 0. So this, if you're asked to graph, example graph y equals 3, then I'm just going to sketch 3 points, right here. And my line will just go through 3 horizontally. So the coordinate is 0, 3, right? When x is 0, y is 3, right? Or if we want to represent it in a formula basis, your actual coordinate will be 0b, right? And that's what you'll plot when x is 0, y equals some type of constant. So what does this look like when you have to graph x equaling a constant? So in this case, it's saying that x, there's not even a line, there's not even an f of x. It's just saying good old x is equal to some type of constant. In this case, it's saying the slope is undefined. That means when I try to find 2 points, find a slope using 2 points, I end up with some type of constant k over 0, where 0 was the divisor. Whenever you're trying to find a slope of 2 points and you have a constant as a dividend and your divisor as 0, it's considered undefined. Also, in some cases, it is said that there's no slope. Not to be mistaken with slope equaling 0. Totally different thing. So whenever you have x as a constant to graph, this produces a vertical line. So your coordinate is actually some value of x, some constant value of x, and 0 for y. So your graph will look something like this. Right? So we have some value. This is my x-axis and my y-axis and my origin. So some value of a somewhere along the x-axis. I'm so sorry. All right. So I'll just graph my line right through it. This is my x equal a. So for example, if I'm asked to graph, x equals 3, I'm going to find my point 3, sketch it 1, 2, 3, right? And then it's 3, 0, so there's nowhere for me to go. And then I just sketch my line right through it. So this is x equals 3. So if you didn't get anything from this, just know when y is a constant, b, right, it produces a horizontal line. And when x is a constant, some constant a, it means that, oh, and in this case, if y is just a constant, your slope is 0. And if you have x just as a constant, it means your slope is undefined or there's no slope, and that produces a vertical line. All right, so now let's get into how we can graph a problem in about 3 different ways. Now, some exams are mean. They're going to be very specific. So if you found one specific way that you understand and that you're comfortable with, and then the exam say, oh, I want you to graph using this method and that method, depending on your professor and what they're looking for. Are they looking for you to graph, or are they looking to see if you know how to use the method? It all depends is how you're going to be graded. But in this case, I want to show you all 3 versions, and hopefully you can get familiar with it and get comfortable with all 3. So here we go. So let's say I have an equation that I'm asked to graph, and it's set up in the general form, right? The general form, so there's 2 forms your equation could be set up at. It could be set up in the general form, which is ax plus by equals some type of constant, or it could be set up in the form as the slope-intercept form, which is y equal mx plus b, where it shows you the slope, which is the coefficient of x, not to be misconstrued with a. Even though a is the coefficient of x here, it's not the slope. It has to be in this form. You have to solve for y in order to find the slope. Solve for y to find slope. All right, so this is my slope-intercept form. So I have a slope, which is m, the coefficient of x, and I have b, which is considered the y-intercept when x equals 0, right? X equals 0. So whenever I substitute 0 for x here, right, b is going to be remaining. It's considered my y-intercept. It's important to know that the y-intercept is not a constant. It's actually a coordinate point. It's saying that when x is 0, y is b. All right. And so whenever you're talking about the equation of the line, it's always good to convert it from the general form to the y-intercept form. This is going to help you graph it for some methods. But for other methods, you can leave it in general form. So the first method I'm going to show you, I made up my own name. I call pull out the sky. Because it's not my favorite method. And when I was learning this method, I felt like I was just pulling numbers out of the sky, right? So what is it you do is that you choose random values for x, and you choose at least 3, right? They say it's always safe to get at least 3 points to put on to graph, and you'll get your graph, right? You get a perfect sketch, not a perfect graph, a perfect sketch. So this means I'll select random points for x and solve for y. Right? So that's what I do there. I select random points for x and solve for y. So I call it pull out the sky, just to be facetious. So usually I select the smallest possible points. So, and depending on my my equation too, like if it have fractions, I'll select a reciprocal of the fraction and things of that nature. So I'll start with like 0, I'll start with like 1, and I wouldn't even probably go to 2. I probably go to -1, things like that. So let's try -1. You can try 2 if you want. So I'm going to select random values for x, and now I'm going to plug it into my equation I have over here. Notice I didn't have to convert into the y-intercept form. I can just find random points right in the general form. And I'm starting with 0. And it shows me that my y will equal 4. So that's one of my point. I have 0, 4. And then my next point I use is 1. And this will give me y equals 4 minus 2. Y equals 2, right? Because this is 2. I transpose my 2 to both sides. And 4 minus 2 is 2. So when y is 1, x is 1, y is 2. And I'm going to use -1. You can use 2 if you want. It doesn't matter. There's infinite amount of numbers that you can use, random numbers you can use in the equation of a line, because the equation of a line has infinite points on it also. All right. So here we go. I'm going to work this out slowly for you. So that's negative 2 plus y equals 4. I'm going to add 2 to both sides of the equation and solve for y. I get y equals 6. So here I have me 3 beautiful points that I am going to sketch on a separate piece of paper because I want to work out all of my methods on this one sheet. Hopefully it works out. So I have 0, 4, 1, 2, and negative 1, 6. So let's see what that looks like on sketch. All right, so I'm going to... So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I have all positive values to the right of my x-axis. Right? I have negative values to the left of my x-axis. And I have all positive values upwards my y-axis. And all negative values downwards my y-axis. And now I'm going to plot my points. And the first point I had, I said when x is 0, y is 4. Right? So that's 0, 4 right over there. Then I said when x is 1, y is 2. X is 1, y is 2. I have another point right here. X is 1, y is 2. And then I said when x is negative 1, y was 6. So negative 1, 6. So right about here, 1, 6. And here I have my line. I'm going to sketch my line right through here. Sketch it, sketch it, sketch it. And this is my 2x plus y equals 4 line for now. So that's one way pulling out the sky method. So let's see the other method. Now this is sort of my favorite method. This is sketch by finding x and y intercepts. Finding x and y intercepts. All right. Now here, I don't have to put in the form y equal mxb either because here is another method of substitution. But in this case, I'm not finding random values. I'm being strategic because for x and y intercept, you'll have a coordinate point that says when x is 0, y is b, and when x is a, y is 0. These are intercepts, right? So for the y-intercept, x will be 0, and for the x-intercept, y will be 0. So here is where I'm going to show the values that I have for x and y in two different cases. So one value, x is my 0, and the next value, y is my 0. So I'll have to find for these letters in the different cases. So when x is 0, what's the value of my y? Right? As we can see, that cancels out. So the value of my y is 4. So my y-intercept is usually represented y dash is 0, 4. You see, that's my y-intercept, right? When x is 0, y has a value. That's my b. And now my x-intercept, I'm going to substitute 0 for y. So here's my equation again, right? Equals 4. And now I'm going to let my y equal 0 and solve for x. So now I have 2x equal 4 and x equals to 2. So in this case, you see my x is 2. So now here I have my x-intercept. It says when I have a value a, right, then my y is 0. So basically, sometimes this kind of trips students up a little bit, like which one is the 0, which one is the x-intercept, which one is the y-intercept. So what I want to just give you a little note here is that for the y-intercept, right, y has a value, right? So there's a constant, right? A constant b. And for the x-intercept, x has a value, some constant a. Okay? So basically when you're finding the x and y-intercept, you're going to find y equals something for the y-intercept and x equals something for the x-intercept. And just know that the missing coordinate point will be 0. So now here I have 2 points, right, that I can graph, and it will, I bet you the graph will look the same. Now, what's also you need to know about the intercepts, if you haven't viewed previous videos, is the intercepts are points of intersections, forgive my spelling, on the graph. All right. So these are points. So it's the y-intercept would be where y-intercept is where line intersects y-axis, and the x-intercept is where I should say where not when, where line intersects x-axis. So here we go. Let's see what that looks like on our graph. So here I'm looking at the same graph that I just used the first method of random values. Now I'm going to look for my x and y intercept. So my first point I found was my y-intercept, which was 0, 4, which is already there, right? This is my y-intercept right here. And then my next point said that when x was, what was x? X was 2. Now remember, this is just a sketch, so it won't look perfect. When x was 2, y is 0. So here we go. Because I didn't sketch it properly, we still see that, it's not sketched perfectly, but we still see the line going in the same direction. We still see the line going in the same direction. It's a poor sketch, so don't use it. If I did this by scale, you would see that it would be going in the same direction. You see, I have a point here and a point here. My line is still going in the same direction. So that's how you use it, by using the x and y intercept. And then the last one I'm going to use now, the last step, well, I ran out of space here, but I'm going to bring over the equation right here. And actually, this one does not cause for any type of algebraic operation, but this is going to cause for me to solve for y. So in order for me to do, this is called graphing using slope and y-intercept. Graphing using the slope and y-intercept. So basically, my equation has to be in the slope-intercept form in order for me to graph using the slope and y-intercept. So I did tell a little white lie earlier that I don't need an algebraic operation. I don't need it if my equation is already in this form. Like, for example, if I had y equals a half x plus 2, then I wouldn't need to do any type of algebraic operation. But because it's in the general form, I have to solve for y. To solve for y to convert to y, to convert to slope-intercept form. So here we go. So I have 2x plus y equals 4. I'm going to transpose the term 2x that's affecting y from being by itself to both sides. So now I have, and then I'm going to write it in the y mx plus b form. As we can see, that's negative 2x plus 4. So here, right, y equal mx plus b, I have my m, which is my slope, which will be 2 over 1, because slope is rise over run. Right? So 2 over 1. And my y-intercept says that when x is 0, then I'll be left with b. And my b here is 4. Right? So I think first what you do is that so what you want to do, so guys, just a minute here. My slope was not 2, my slope is negative 2, right? Negative 2 over 1. Now you can choose to do negative 2 over 1, or you can choose to do 2 over negative 1. It wouldn't matter, right? It just simply means, negative means I'll be going down instead of up, and then going to the right, right? Down and right. Or I could be going up and left. It wouldn't matter. Up, then left. All right, you can pick the negative for any one, for the rise or fall, or for left or right. So what I do when I'm using the slope intercept form to graph, first I'll plot my slope, right, which is already there. You see, it's already there, right, from the previous methods. And then I'm gonna choose to go down 2 and to the right 1. So if I go down 1, 2, and I go to the right 1 place here, I have a point right here, and I could connect the two. You see, they're the same. Or let's say I wanted to go up. From the slope, I could go up to 1, 2, or 1 over to the right place, which is right here. You guys see that? Isn't that beautiful? Oh my goodness. So yes, guys, this is how you graph using the 3 different methods. This video is already 20 minutes long. I don't want to exhaust you. Hopefully you got the point. Give it a try. Try an example of the equation. Look at the video again and see if you're making the right steps. All right, good luck. For my students, if you need help on this further, you know how to reach me.